Lesson 5.5, roots of real numbers. We're going to look at simplifying radicals in this lesson, finding roots, and then also some more stuff with a little bit more complex roots. But basically it deals with radicals. Now the first thing we're going to look at is a table here with some powers on it. Some things that, this will be on a help sheet that will be given to you, but we're going to look at perfect squares, perfect cubes, perfect powers of 4, perfect powers of 5, and a couple of perfect powers of 6. These are used, or will be used in the next few lessons here to help you simplify radicals. Okay, so if you look at this first column, it's the values of n. So I've got n from anywhere up 2 through 10. We don't start with 1 because 1 to any power is 1. That doesn't help us to simplify radicals. If you look down the n squared columns, n squared, so you've got 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are the perfect squares up to 100. In other words, they have whole number square roots. Perfect cubes, we've got 8, 27, 64, and so on, all the way up to 512, which is 8 cubed. This is just a helpful table to help you simplify roots, which we'll be doing in the next few lessons. Alright, so let's get into simplifying radicals and finding roots of things. So, what the first thing they're telling us here, if you look at the first of these three problems, is simplify, okay, and you have a positive and negative. So a positive and negative right here, okay? Positive and negative square root of 16x to the 6th, okay? When you have a product underneath there, in other words, you have a coefficient and a variable to a power, what I tell kids to do is to kind of think of it this way. The positive and negative symbol is just going to be carried with us and will be the sign on our answer. But I say let's look at the square root of 16, so the square root of the coefficient, and then let's look at the square root of x to the 6th. Okay? So 16 is a perfect square. The square root of 16 is 4. Okay? X to the 6th is a perfect square. Okay? Some ways of simplifying x to the 6th. And basically, if it's the square root, which is what this index is an index of 2. If this exponent right here is even, the square root of x to the 6th will be x to the 3rd. A way of getting that is to take the power on x inside the radical 6 divided by the index 2. Okay? Another way to think of it, just to give you some alternative methods and see what you like best and what's easiest for you to understand, is if we had the square root of x cubed squared, well, that would be x cubed, because x cubed squared is x to the 6th. Another way of thinking of it is if you think about fractional exponents. Remember a little bit of review here. Fractional exponents, square root means something to the 1/2 power. And we'll get to other roots besides square roots later, but cube root means whatever's underneath the radical to the 1/3 power. Fourth root, so the fourth root of something means whatever's under the radical to the 1/4 power. So some things to keep in mind. Another way of thinking of this is what you really have is the square root of x to the 6th. Well, that's x to the 6th. Square root means 1/2 power. So x to the 6th to the 1/2 power, power to a power says I multiply exponents. Well, that would be x cubed. So that's a way of thinking of it as fractional exponents also. I don't really do that with the number part. I just simplify that square root, but I'm talking with the variable parts. That'll help you with exponents. Okay, so your answer here to this first problem is 4x cubed, and don't forget we've got positive and negative. That's just the sign on the answer. Okay, if you look right here at this next problem, again we got a negative out in front, so that just means that's going to be the sign on our answer. We've got a power of 4 right here, but we have square root. okay, which is an index of 2. So thinking of like I talked about the earlier one, q cubed plus 5 is in parentheses. We're going to take and we're going to divide this 4 by the index 2, which is squared. And we're going to leave it as negative q cubed plus 5 squared. Okay, and for what we do, we'll let you leave it as that answer. Okay, you could actually square the binomial and then distribute your opposite through, but we're going to actually leave it right there as that and let you stop there with that being simplified. Okay, another way to think of it is you have q cubed plus 5 to the 4th. Well, all that, I want the square root, and it just means you have a negative on it. Okay, square root means 1/2 power. Well, power to a power, you multiply exponents, so it's q cubed plus 5 in parentheses. 4 times 1/2 is squared, and again, this negative sign gets put on it. So that's just a way of thinking of it with fractional exponents, kind of like I did the first one. Just some alternative ways of doing these. Over here, now we have a 5th root. Okay, so I want to do the 5th root of the coefficient, which is 243. And then I want to do the 5th root of a to the 10th, b to the 15th. Okay, if you think back to your sheet here, the 5th root of 243, if we look back down the perfect powers of 5, if you notice 243 is down your end of the 5th column, it is 3 to the 5th power. So the 5th root of 243 is 3. Okay, simplifying this part of it, okay, one way to do it is to take the power on a, divide it by this, okay, divide it by the index on the root, which in this case is 5, so that would be a squared. Do the same with b to the 15th, divide that exponent of 15 on the b by the 5, it would be b to the 3rd. So I have 3 times a squared b to the 3rd, and that would be my answer right there. Another way of doing that variable part is to do a to the 10th, b to the 15th, and we want the 5th root, so that's the 1/5 power. Now if I do power to a power, power to a power says you multiply exponents. 10 times 1/5 does give me the 2 there. Same thing, 15 times 1/5 does give me the 3 right there. So 3a squared b cubed is your answer to that problem. Okay. If we go to D, we've got the square root of -4. If you try to do this on your calculator, it gives you an error message. Okay, until we get to talking about imaginary numbers in a few lessons down the road here, this is a non-real number answer. We cannot take the square root of a negative. If it was square root of 4, obviously it would be 2. Okay, we'll get to the imaginary unit I and dealing with complex numbers and that at the end of this chapter. Okay, so this is a non-real number answer because of a negative underneath the root. Again, it's because of the negative underneath the root. If you have the square root of a fraction or any root of a fraction, what I tell kids to do is to separate it into the square root of the top or the root of the top over the root of the bottom. And if you notice, both 1 and 9 are perfect squares. The square root of 1 is 1. The square root of 9 is 3. So it's 1/3. And try and leave them in simplified fraction form. Okay, if we go over here, now we're dealing with a cubed root. So I want to do the cubed root of 1 over the cubed root of 64. And if you notice, those are both perfect cubes. Cube root of 1 is 1. Cube root of 64 is 4. So the answer to the cubed root of 1/64 is 1/4. Come down here, square root of 4/9. So it's kind of like what we did the square root of 1/9. It's the square root of 4 over the square root of 9, which is 2/3. They're both perfect squares. Here we got a cubed root example. So we're going to do the cubed root of the top divided by the cubed root of the bottom. Both of those are perfect cubes. Cube root of 8 is 2. Cube root of 27 is 3. So it's 2/3. Okay. Last one here. Square root of a negative is a non-real number answer. Again, because it is the square root of a negative. Okay. We'll talk about the imaginary solution to that, like I said, at the end of this chapter. Okay. To finish up this lesson, we're going to simplify. Now, the book calls it simplifying using absolute value. What we're going to allow you to do is to ignore principal roots and absolute value in answers when you're checking answers in the solution key. Okay? Don't worry about that. If you have the answers without what the absolute values around, that would be the same thing. So just kind of ignore any absolute value. If you take out the absolute value bars, if you have that answer, you are correct. Okay, t to the 6th, we're taking the 6th root. Two ways to think of it. I can divide that number by that. It divides out evenly. It's t to the 1st or just t. Or think of it like I've been leading you into fractional exponents. T to the 6th is what's underneath the root. I want the 6th root, so that's 1/6 power. Well, if I do my power to a power, I multiply exponents. 6 times 1/6 is 1, so it's t to the 1st. Over here, now notice you've got a number part there, and then I have my binomial x plus 2 to the 15th. So what I'm going to do is I'm going to kind of separate this into the 5th root of 243 times the 5th root, and then underneath we're going to have x plus 2 to the 15th. 243, if you go back to your sheet that has the perfect powers of 5, or the perfect powers on it, if you go back here, 243, we did that one earlier, is 3 to the 5th power. So the 5th root of 243 is 3. So this will be 3. What we're going to do here is we're going to take this power, divide it by the index. So I'm going to have times x plus 2, that binomial, to the 3rd power. Or you can think of it this way, x plus 2 to the 15th, and we're going to raise that 5th root to the 1/5 power. And what I would do right there is I would multiply the powers there, power to a power. 15 times 1/5 does give you 3. Now, you could expand this further, but we're going to let you stop because we're just kind of looking at the radicals and the root rules. You could go through and cube x plus 2 and expand this a little further, but we're going to let you stop right there.